last new stuff. In this class, we're going to look at several theorems about definite integrals, and we're going to investigate the area between two curves. Okay, take-home quiz is being handed out today. Make sure you get one. Don't leave here without one. Don't let me let you leave here without one. All right, what do you think happens if the limits of integration on a definite integral are the same number? So I want to take the integral from 2 to 2. Or what if the smaller number is on top? So I write the integral from 5 to 2. Okay? So here is what we do in each case. The definite integral from a to a of f of x dx, what do you think that would be? It's just the height, and what would the width of that rectangle be? 0. So what would its area be? 0. Yeah. So the width of a rectangle that goes from A to A is 0, meaning the whole area is 0. We define the integral from B to A, where B is the bigger number, right, to be the opposite of the integral from A to B. You just put a negative sign in front and switch the limits to make it look normal. Okay. You can think of that as like going backwards in time if you're looking at the area under a velocity curve. Yeah, so it's just negative, yeah. All right, so a couple quick examples. What's the integral from 3 to 3 of x plus 2 dx? 0. Don't even have to do any calculations. Me too. All right, the integral from 1 to 0 of radical 1 minus x squared dx. And there's a picture here to go with it to help you find that area. Yeah. Here's 0 to 1, so I'm looking for the area of this pizza slice, really big pizza slice. And the area of a circle is pi r squared. The radius of this circle is 1, and this is a quarter of the circle, right? So its area is going to be pi over 4. That's its area. But the integral is the integral from 1 to 0. They put the bigger number on top. So this is negative the integral from 0 to 1, make it look normal. So then my answer is negative, and then the integral from 0 to 1 is pi over 4. Is that okay? Yes, it's above the x-axis, which means that the integral from 0 to 1 of radical 1 minus x squared dx is positive pi over 4. And I just have that negative in front because I switched the limits of integration. Okay, so if we think about the geometry of areas, then we should be able to fill in these rules that we have about integrals here. So the integral from a to b of f of x plus g of x dx is just the integral from a to b of f of x dx, the area under f plus the area under g. So if you have two functions, f and g, you could add them together and then take the area underneath, or you could take the area underneath one and add it to the area underneath the other. It's going to come out the same. Same thing with subtraction. And if you had a function f of x and you multiply it by some scalar, so it would be like a vertical stretch of that function. Remember vertical stretching from a college algebra class? So you've got some function and you're doing a vertical stretch of that thing. You're going to multiply the area underneath that curve by the same amount. So this is going to be just c times the area under the curve. So if you have a scalar, you can pull it right outside the integral. Oh yeah, we're going to do that in a minute. Yep. All right, so if I want to take an integral from a to c and then add an integral from c to b, if you picture c being some x value between a and b, this seems really obvious. So c is going to be a value between a and b, so I'll draw a picture of it. Oh, I have a picture. Good. All right, so I've got an interval from a to b. So what I want to do is take the integral from a to c, which is this area, and add to that the integral from c to b, which is this area, which is the same thing as if I just went directly from a to b and took the integral from a to b of f of x dx. Okay, so using our rules and the fact that I know the integral from 0 to 1 of radical 1 minus x squared dx because we did it a few minutes ago up here. I'm going to use my rules and the area of a circle formula to come up with this integral. So first of all, this is a subtraction, 5 minus 3 minus radical x squared. So I can break that integral into two. This will be the integral from 0 to 1 of 5 dx minus the integral from 0 to 1 of 3 radical 1 minus x squared dx. And then I can take that 3 and I can pull that outside the integral from property C there. You take the scalar outside. So this becomes the integral from 0 to 1 of 5 dx minus 3 times the integral from 0 to 1 of radical 1 minus x squared dx. So how do you calculate the integral from 0 to 1 of 5 dx? What does that mean? It is, but 0 to 1 is the typical way that we write it. You could flip it and make it negative, but the way it's written, it means the area under the curve. There's no reason to flip it, but it's true. It's just not going to help us with anything. So if I draw a picture of that, my function is just the constant function 5. So here's my function 5, y equals 5. And I want to find the area from 0 to 1 under the curve. It's 5, yeah, because it's just a rectangle that's 1 by 5. So this is 5 minus 3 times, and then the integral from 0 to 1 of radical 1 minus x squared dx, we did that earlier, and it came out to pi over 4. So my final answer is 5 minus 3 pi over 4. Questions so far? All right, well, that's all I got for demo anyway. The rest of it is for you to work on. And I will help you if there's anything that's still confusing.